This is section 10.3, part 4. All right, we've got one more example to look at before we talk about practical significance. So let's take a look. All right, in this example, we're told that a biologist was interested in determining whether sunflower seedlings treated with an extract from Vincia minor, I think I'm saying that right, roots resulted in a lower average height of sunflower seedlings than the standard height of 15.7 centimeters. The biologist treated a random sample of 33 seedlings with the extract and found the mean of the sample to be 13.664 centimeters with a standard deviation of 3.544 centimeters. Test this claim with a 2% level of significance. So first off, we can see that yes, this is less. The sample mean is less than the standard height. We just want to know if it's significantly less. So this statistical significance that we're testing for using our hypothesis test is what we want to determine. All right, so first of all, let's make sure we meet the conditions of the t-test, and then we'll set up our hypotheses and run through our calculator steps. All right, so as we look through our conditions, we are told that we have a simple random sample. That simple random sample is of n equals 33 saplings. So boom, both of our first two conditions are set right off the bat. We also want to double check that we're taking a small enough sample. And of course, anytime we're taking, like double or even triple digit, something in the hundreds, we're probably going to be safe, but it's always worth checking. And in this case, it's always kind of like a nice thing to think about is, what would be my population size? I don't know, but in this case, I'm basically asking once I divide this over, so just going to divide by 0.05, I'm going to get 660 is less than our population size. So as long as it's reasonable to say that there are more than 660 sunflowers of this particular variety out there, then we're good. And I think that's very safe to say. So this is not saying, 660 sunflowers on a particular farm. It's saying that, across the country or even across the world, do we have enough, is our population bigger than 660 sunflowers? And again, I think that we are perfectly safe in assuming that. So we're going to go ahead and give that a big old check mark too. All right, so we've got our information pulled from the problem here. The standard mean that we're expecting to have, which is 15.7 centimeters, and then our sample data, as well as our significance level. So the first thing we want to do is come up with our hypotheses, and I'm going to put those over here at the top. I'm going to say that the null hypothesis, of course, is always just that it stays the same. So if this extract does not change the height, then we will just assume that the mean is the same as if it were coming from a population of sunflowers that had not been treated. And then our alternative, of course, if we look back at our problem, was to tell if they were shorter, if the height would be less. So our mean will be less than 15.7. And of course, our preliminary results, our sample value, does suggest it could at least be less than. But we never want to just go with, well, this one sample was less, so we should be fine. We always want to make sure that we have evidence with our significance level and doing the hypothesis test. Is it not just less than, but is it significantly less than? That's what we want to know. So there's our hypotheses, and I'm going to go into my calculator. I've already got to the test menu. Of course, we've done that. We've gotten here before. So stat, over to tests. And then I'm going to go down to t-test. I'm going to go back to stat. So we just did one with data, but I'm going to go back to my statistics option for input because I have statistics given to me. And of course, I'm going to change my null hypothesis here to match up with the null hypothesis for this problem. I'm going to input these values that I have for the sunflowers, the 33 sunflowers that were tested. So our mean, our standard deviation, and of course our sample size is bigger now. And instead of being greater than, we want to use that less than sign. So I want to make sure and go over here and switch it. There we go, switch. I hit the down instead of over. There we go. And now we can calculate. And we see, of course, that we match up our alternative hypothesis matches with what our calculator did a test for. It's always handy to make sure that that happens, because like I said, you can end up just forgetting. Enter, you go down to calculate, and this could be looking in the wrong direction. Or it could be not equal and need to be directional, or vice versa. So we always want to just make sure we check that. And then again, we'll calculate we've got our test statistic here, 3.3, negative 3.3. That is basically more than 3 standard deviations away from the mean. So that alone kind of tells us, oh, this is kind of significant. It's pretty far away. But of course, our p-value is what we really want to do. So we want to check our p-value versus our significance level. And we've got 0.001. That is definitely less than 0.02. Since I have such a small p-value, that means that this is an unusual sample. We would not expect to get this sample mean if we were just pulling from a population of regular sunflowers. Instead, we have sunflowers that were treated with a particular extract, and it seems that we have the evidence to show that that has affected the height. So we are going to reject the null hypothesis. All right, so I've put our claim back up here at the top just so we can write our conclusion with the correct context. And so remember, we rejected the null hypothesis. So yes, we rejected the null, therefore there is sufficient evidence. At the alpha equals 0.02 level, oops, left my E out, of significance to suggest, and then I'm just going to go up here and basically rewrite the what they were trying to determine. So to suggest, and I'm going to start right here, sunflower seedlings treated, oops, I can't erase. All right, treated with Vinca minor. Again, I'm not sure if I'm saying that right or not, but we're going to assume I am. Roots. Oh, let's see. With an extract from, there we go, Vinca minor root, plural, results in a lower average height of sunflower seedlings. There we go. All right, so again, just quick reminders. We have the evidence because we rejected the null hypothesis. That's the only way we get evidence, is if we're able to reject the null. We want to make sure we include our significance level, and then we want our context. So there we go.